What's up everyone? Today we're going to take a look at an AI that teaches itself how to play NIM through reinforcement learning. Now if you're not familiar with the game, in this game you have a bunch of piles and each pile will have any number of objects, and then players take turns removing one object or any number of objects actually from any one pile. And then the goal of the game is not to be the last player to remove the last object, because the player who removes the last object will lose the game. So if it's my turn, for example, and this is the current game state, I can pick the first pile and then say I can either remove one, two, or three objects from that pile, and then it will be the next player's move. And the way we're going to use this and do this, instead of teaching our AI how to play the game through minimax or the likes of which, we're going to actually use Q learning to let the AI play a bunch of games, and then based on the performance and the feedback that it gets, it will improve its performance. And again, Q learning will just keep improving it. Each time it takes a move, it will get a reward that's based on the value of the current move and the best possible action it can take from this new state. And we'll keep updating our Q learning, or our list of QSA. And also going to be using the epsilon greedy algorithm so that the AI can explore possible new actions even if their values are not as good. This way it can alternate between exploring and exploiting. And let's run the game here. So we're going to train our AI to play, actually let's set some breaking points before I forget. Yep. So we're going to train our AI to play 1000 games, and then we're going to play against that trained AI and see how well it performs. So here at the once we start the game, if we look at the player, we'll see that it has no values for any cues. Then it plays one game, and each move on each action on a given state starts getting a value, which would actually be simplistic at first. But then if we let the AI play its 1000 games, we'll see that the value it assigns for each action on a given state becomes more complex, and the more games it plays, the more complex the values become and the better it performs. So yeah, if we look here, let's go downwards the AI. Yep, at our AI here, we'll see that the list of Q values are now really complex and can determine, and even the AI knows instances where if it's in this state and it takes this action, it automatically loses, so it wants to avoid that. But yeah, let's keep going here and remove this one as well. And so this is the starting game. It's the AI's turn. Oh, whoops. So the AI chooses to take 7 from pile number 3. Okay, it's my move. I'll say the pile number 0, and I'll take 1 from there. AI takes 3 from the first pile. Oh wait, then I can win. 2, and I remove 4 from that. Yep, so the winner is the human, because the downside of Q learning or any reinforcement learning is that the AI needs to play a ton of games. So it could even lose after playing 1000 practice games. But actually, if I let it here play 10,000 consecutive games, we'll see that its performance will improve drastically. So yeah, let's give it a minute here as it plays 10,000 games. Actually, how long have you been running? Yep. Yes, 6,000 more games to go. And we're halfway through. Almost there, almost there. Uh, Stay with me, don't leave the video. It's almost there, it's almost there. And yeah, oh, one thing I should note is that obviously if you're keeping track here, the AI, this kind of task is computationally demanding, because now the AI needs to keep track of the scores of 10,000 different games. But yeah, anyhow, this time I'll get to go first. Okay, let's see. I'll pick the first pile. I'll take 3 from there. And then it's the AI. It takes 1 from pile 3. Okay, I'll take 1 from pile 2. And it takes 2 from pile 2. Okay, then let's take 1 from pile 2. Okay, I think I lost. Okay, pick file two, take one, then it takes one from any of the files, then yeah. So yeah, the AI won this time, and so we can see how drastically its performance changed. It now computes and it makes better actions. And overall, even if you can't tell its composition or the Q values it has, you can see how its values are very well computed and it knows what to do because we made it train with enough games. So that's all for today. Hope you enjoyed and have a nice day.